Hi, everyone. Welcome to our webinar on AI workflows and data collection with Databricks. My name is Mary Kirshner, and I lead customer success at FocalCXM. Before we get started, I want you to know that we will have time at the end for any questions or comments. So please post your questions to the Q&A link. We will address them at the end of the presentation. Today, we'll be doing a deep dive into the latest advancements transforming how organizations manage, collaborate, and innovate with data on the Databricks platform. We are very happy to have Venkata Jyothi Kotra and Aditya Madaneni with us today. Jyothi is the Director of Data and AI at FocalCXM and oversees the data and AI solutions in both the commercial and public sector. Additionally, she serves as an adjunct faculty member for data analytics at South New Hampshire University. Jyothi has extensive expertise in data modernization, architecture, governance, and enterprise modeling. She's a pioneer in next-gen tech solutions and is well-versed in big data, cloud computing, distributed data processing, system upgrades, and business process transformation. Aditya holds a master's degree in data science and specializes in applying Gen AI solutions to solve complex business challenges. He has demonstrated expertise in leveraging advanced data-driven technologies to foster innovation and efficiency across various industries. Thank you both for being here with us today. Jyothi, I will pass this along to you.
Thanks, Mary, for the introduction. Hello, everyone. I'm Venkata Jyothi Kotra. Thank you for joining today's webinar. We will dwell deep to learn secure and trusted data sharing, how Marketplace works in Databricks, and how clean rooms operate. And in addition to that, advanced RAG concepts like chunking strategies and query transformations. So here is a quick peek at the agenda today and topics to be discussed in the webinar. First, we would start with data sharing on Databricks, how collaborative model sharing works on Marketplace, what are clean rooms, what are some advanced RAG strategies, and how to implement them in Databricks, followed by a demo and Q&A session. First, I would like to introduce FocalCXM. FocalCXM is dedicated to enhancing employee and customer experiences through utilization of data, artificial intelligence, and Salesforce. FocalCXM has achieved success in delivering diverse data and AI services to esteemed clients and stakeholders. In addition to that, FocalCXM and Databricks are trusted partners and play a crucial role in advancing lakehouse architectures, enabling organizations to harness data and AI solutions effectively while maintaining trust and compliance. So let's delve into the topic now. First, data sharing. What is data sharing in Databricks? So there's a lot of data sharing protocols currently in the market today, and there are also traditional data sharing protocols like SFTP, file transfer protocols, API-based file transfers. Data sharing in today's world is very, very important. Because the data for any organization, the data is the key, and mainly for data-driven innovations, data sharing and collaboration of data and models is very, very important. Databricks provides data sharing as a secure solution for sharing live data from Lakehouse platform. So from the Lakehouse platform to any computing platform without replicating or moving data to another system. It's a share of live copy of data. That's the importance of data sharing solution within Databricks. Before understanding the importance and also the advantages of data sharing on Databricks, first let's see why is data sharing and collaboration so important. So data sharing is crucial in today's economy for businesses to exchange many of the data sets which are in today's world. For example, for life sciences company, open FDA or clinical trials data or health diagnosis, ICD data, many data sets which are common for many organizations. If we take retail sector, a company who is trying to do the retail business and then the company which is trying to manage the customers and loyalty, they still have the same similar data sets, even though they are two separate organizations, but they share the same customer data. One as a retailer or a provider of the business, and other as a customer loyalty and management service. So the data is the same for many organizations, or at least some of the data sets are very similar. So data sharing is very crucial for organizations today. And if one org has done already the curation, ETL, management of data sets and all that, then that data can be right away provided as a shared data set to the other org, being a provider and consumer, and maintaining that trustful relationship of being a data provider and data recipient, so that many of the redundancies can be decreased and innovation can be at scale. So, lack of standards in the traditional world, in the traditional data sharing practices, the main disadvantage is lack of standards on data sharing protocols. And in today's world, there's many data regulations like GDPR, CCPA, HIPAA, and the data sensitivity, levels of data sensitivity necessitate a secure platform for data sharing. So the industry needs, in the current market, the industry needs an open approach for data sharing. That's where Databricks data sharing comes into play. So how does this data sharing work on Databricks data sharing? So mainly it is a simple scalable solution provided by Databricks and very cost effective, so that the organization can immediately start acting as a data provider, and any orgs can be start acting as a data recipient. An organization can play two roles. The organization can be data provider and sharing the data sets to other organizations. At the same time, the organization can also play as a data recipient. So it is natively integrated with Unity Catalog. Uh, Unity Catalog is one of the important key concept of Databricks, where it maintains the regulation, compliance, and governance and security of the data in a unified platform. In addition to that, it maintains the audit and logging as well. So when the enterprise level data is being shared to the other organization, there is a lot of concerns on data security. And when the data is flowing from the current tenant, organization tenant to other tenant, there's a lot of questions on security and governance of the data. So all this is being managed by Unity Catalog, and it is so fine-grained that it can manage the sensitive data sets even with data masking and encryption. So it's a simple REST protocol for secure data sharing, meaning that the data which is in transit and as well as data in rest, every flow of data layers have been completely encrypted, and they meet the standard security protocols. In addition to that, the data sharing which has been set up on Databricks, mainly the advantage is it can support any use case. Let it be analytics, it can directly integrate with Power BI, Tableau, many of the visualization tools currently in the market. And for the business intelligence use cases, directly the data sets, curated data sets can be consumed from the data provider and build analytics on top of it without no need of doing ETL on top of it, or no need of doing additional curation. Directly, the curated data set can be taken right away from the data provider and start building analytics on top of it. That way, innovation can be at scale. And in addition to that, it supports the AI and modeling. How easy it is if an organization one has done the model training. For example, there's a huge address data by USPS. Already, the whole model has been trained for many of the use cases, and then that same model can be reused by the organization too, because it is already pre-trained, it is already having good accuracy and achieved accuracy. So the organization too can right away consume that model either at free of cost or at a paid cost, but lot of resources, time and effort would be saved by using that pre-trained model, and then build their own organization level data analytics on top of it. So that's the ease of data sharing on Databricks. And what is another advantage? Any cloud platform can integrate directly to this data sharing. So let it be Google Cloud, AWS, Azure. So all platforms and any tool can integrate directly to Databricks data sharing. So Databricks Marketplace. So this is one of the important concept on Databricks, which is built on top of Databricks Delta Sharing API. So there is a RESTful API of Delta Sharing, and Databricks Marketplace has been built on top of it, which acts as a bridge between the data provider and data consumer. And mainly, this is improving the data-driven innovations. The innovation can happen at scale. There is a different organizations, but they still use the same customer data set or product data set or product catalogs or open FDA data sets or any other data sets which are publicly available. So that data sets are can be reused. So the organization 1 and organization 2 doesn't need to do the additional curation. So one organization has done the curation and they have developed some features, they have developed some metrics already. Then right away that data set can be taken by organization 2 and join with their own data and join with their own primary identifiers and data sets, and then they can do their own analytics on top of it. So it reduces so much of data processing time and right away helps in data innovations. So that's how Databricks Marketplace helps scaling the innovation and creativity of an organization. So rather than talking about marketplace, I would showcase how marketplace is very important for both data providers as well as data consumers, and how it provides new offerings of data. It not only data, it can share any possible data sets, like whether it is tables, models, notebooks, even private data exchanges are possible by Databricks Marketplace. I would like to talk about one more important topic, which is Databricks Clean Room. So, Clean Room is a secure, collaborative analytic platform, which takes the concept of delta sharing and it just adds on top of delta sharing. And then a Clean Room is a clean space for an organization where they can use that clean space to have the data set, and then directly, for example, there's a collaborative one, the company organization one, which have their data, they have their tables, and then that tables or data needs to be data shared with organization two, and then they use the same data set. But the collaborative one doesn't, they have their own sensitive data set on top on this table, which collaborator 2 doesn't need to see that data, but they want to link their data to this existing table. So in that case, Databricks provides a solution called clean rooms. So the mutually approved data sets, mutually approved notebooks, mutually approved jobs by two collaborators can be located in a centralized location, and this central location is managed by Databricks. And then this location provides a complete trust and compliance, because it is sitting on top of Unity Catalog governance, and then that provides, like, so any job which is kicked off by collaborator 1, a job which is kicked off by collaborator 2, both jobs would run in the central platform and it fetches results, and collaborator 1 can only see their own data, and collaborator 2 can see only their data. So the table which has been shared by collaborator 1 to collaborator 2 can just see the schema and metadata of the table, but they can't see the actual data itself. Still, they can use the internal data and fetch the results on top of it, like aggregation or summarization metrics. So that way, complete data security it has been set up with clean rooms. In addition to that, how does this clean room work? So as I said in the previous slide, the collaborator A has like tables and volumes which needs to be shared with collaborator B. And on top of that, like for example, this is a retail org, and then this is like a customer management or CRM org. And both the organizations are still dealing with the same customer product data, and then they are still dealing with the similar data sets. But the organization 1 doesn't want to share the customer date of birth or any PII with the organization 2, but they want to share some data. They can always mask the data or share only the tables metadata and only table schema, but still put the tables and volume into the clean room. So the clean room actually, even before running the code, it maintains a no trust environment, which means that the data which has been landed into clean room needs to be mutually agreed, and mutually agreement needs to happen on data sharing. And then even the notebooks which needs to run on clean room needs to be mutually signed off. So that way, like, both the collaborators are in agreement that the data can be shared, and then no other collaborate. This clean room is exclusive for these two collaborators, and no other external collaborator can see this data or can visualize this process or can run this process. So no penetration can happen in this clean room. So that's how the whole security is maintained. But this collaboration can happen between two partner orgs. So this is very, very advantageous in many of the industry use cases. Let it be retail org, let it be life sciences org, a regulate where the data is in high regulation. This private data exchange is very, very important because of the security and sensitivity of data. Clean rooms make it possible and make it happen by maintaining a no trust environment. The whole model of clean room is set up such a way that it ensures equal privileges for all the collaborators. So the creator and as well as collaborator has the equal responsibility of the data sharing, and also the security and vulnerability, everything they need to take equal responsibility. And all the collaborators need to approve a job or notebook before running it, and at the same time the environment is completely locked down for the collaborators and no new collaborator can enter into that space. So that way the data is very secure, and then the data which has been built and model which has been built by organization 1 can easily be used by organization 2 within this secured clean room, and then it maintains complete trust between the two orgs who are sharing their data within themselves. So that's how the clean room works. With this, I will move on to demo of these concepts. Hope everyone can see my screen. So first I will try to demo how data sharing works, and then I will move on to some explaining how marketplace works. So I talked about data sharing. So that the way the data sharing works is that going to the catalog on Databricks and then selecting delta sharing over here actually brings the provider to the delta sharing space. And here, like the customers would see the data which has been shared with them, and also an option of the data which has been shared by them to the others. So in Databricks terminology, shared with me is nothing but this provider is acting as a recipient over here, and shared by me is nothing but this is the provider of the data. So personally, I am the data provider to the recipients, and then I have shared these data sets and notebooks to some recipients. So to create a recipient over here, data recipient over here, mainly there's two types of protocols on data sharing. The first kind of protocol is if the recipient is a Databricks user, then directly we can share the data with the sharing identifier. The Databricks to Databricks sharing is very powerful. For example, organization 1 uses Databricks and have Databricks in their current architecture, and organization 2 also has Databricks. Then this is like Databricks to Databricks sharing protocol, and it makes it very easy to share the notebooks, to share the code, to share the common functions. Everything can be shared from one Databricks workspace to other Databricks workspace using a sharing identifier. So that's how the sharing between Databricks works. And then what if the organization which currently I am on, I don't have Databricks, and to use this feature, do I need to have Databricks? The answer is no. If you have any infrastructure, whether it is like a simple MySQL server, Pandas platform, or you have like any Java based, any platform can directly integrate. Even a Power BI can directly integrate with this, and then use this data sharing protocol. So for the interest of time, I already created some recipients. So here the difference between the authentication type shows the difference between whether the user is the Databricks based share recipient, or else the user is like a token based shared recipient. So that's how it is. So what is a token based shared recipient? Here it is important to understand that when we are trying to create a new recipient, who doesn't have Databricks platform and they want to still use the data set, then Databricks actually gives a particular a way to actually create this data share. So here, when I'm trying to create a new recipient, so here, like when I try to create a new recipient who doesn't have Databricks, here it gave a link to actually navigate to get the token. So once the user actually goes to this URL, then they can download the credential file which has the secured bearer token, which can connect directly to this Databricks API. That way, the data assets can be shared directly. So that's how the token based sharing would create the activation link. And then directly, once the activation link has been done, we can directly do grant a share to that particular recipient. So for example, I have created a recipient now and I'm trying to use this share to that particular user. And then we also have additional control on top of this where we can allow a specific IP address only to access this data. So that way it is like additional control on data where only a particular users can actually through some IP addresses only can actually consume the share. So that way the data security, additional level of security can be maintained on top of data which has been shared. So that's how the Databricks sharing works. I have pre-prepped some share over here to showcase how the open sharing protocol works. Totally understand that Databricks to Databricks sharing is very easy because it just uses a sharing identifier, and from one workspace, the data can be directly ported into the next workspace. But what if I don't have a Databricks? I can still take the shared data, and then this is like just a Jupyter notebook. It is not Databricks. It's an open source Jupyter notebook from my local. I can still access the data sets which have been shared over here by using Delta sharing. So I have used Delta sharing and then taken all the used the config share file which has been created, the token which has been created, and then from there I have directly taken all the tables which are in the share. So I created a test share and a schema and then some tables under it, and then I can directly see those tables and I can query those tables also right away over here. So that's how the open share protocol works. And then not only this tables which have been shared can also be consumed using Power BI, Tableau, or any platform for that matter, and directly use this data sets right away. In addition to that, I would like to talk about marketplace. So this marketplace is actually built on top of Delta sharing. So here, Delta sharing actually the API, the marketplace sits on top of the API, and then here the main advantage of Databricks market sharing is that it can use like monetization of the data sets can happen at the same time. Any data sets as a provider, we can publicly publish them onto Databricks, and then it can reach n number of customers. So that way there's a lot of growth for the business, and on top of that also trying to use act as a provider and also act as a recipient improves the collaboration with other industries and other organizations. So here, there's many providers who have published the data on the Databricks. Depending upon the category, there's many, but I would like to showcase one or few for the interest of time. For example, I would like to go over the IQVIA data sets which have been published on Databricks. So here, mainly the thing we have to see here is that the data is by paid, which is like it is monetized data set, and at the same time the visibility is public. So we could set the level of sensitivity of the data, whether the data is private or public based on the nature of the data set. And also this data would be available only by requesting access, and then there would be some price associated with it. And what is the advantage of this? Like directly this data set can be consumed, and the tables would be directly ported to our own workspace. So I can show like one of the data sets where I have actually went into the free data set directly, and then its the pricing is free, it's public, and I have actually enrolled for this access. And once I have enrolled from marketplace, directly the data would be within my catalog, and the tables are also like ported directly within my catalog, and I can right away use this table. This curated data set can be right away used with for analytics. So that's how easy and simple that I can use other providers data sets by requesting access, and also by trying to meet all the agreements, and I can use the data right away. This is not only data, we could also use the models. There's different categories of products which can be shared on marketplace, like tables, files, models, and solution accelerators. So all this can be published into Databricks, and then right away the organizations can act as providers and as well as recipients of data. So that's how marketplace works. And in addition to that, not only the data sets which are publicly available, there's an option of private exchange. So there's a sensitive data set, and there are two orgs which maintain which have like a regulated data set. Then that can be done as a private exchange. So in private exchange, there is an option where we can choose the recipient of the data. So that way the data security agreements can happen between the collaborators, and then that way the data exchange can happen. So this is how the data sharing on Databricks works. So primarily the data set which I have shared from this workspace to the other workspace, mm, I wanted to, in this demo, I just wanted to show like how I can share a data set for the recipient itself. So here I have shared two data sets. I can also share like more data sets by granting share to that recipient. And the data sets which I have shared over here, the recipient directly, they can see the shared data sets within the shared catalog over here. And directly they can use the data sets which have been built in one workspace, which is provider workspace, and they can use the same tables in the recipient workspace. So that is so easy to take a data or a model which has been built in one organization, and the same level of effort, resources, money doesn't need to carry out to the other org, but directly they can use a data set right away into the other org. So that's how Databricks data sharing, marketplace, clean room, all are built on top of the same concept of secure data sharing using Unity Catalog, secure governance. So that way it enables the industries to share data and collaborate with each other very well. With this, I would like to pass on to my colleague Aditya to talk about the advanced concepts of RAG.
Thank you, Jyoti. Hi, everyone. Very good morning and good evening, all. Thank you for joining us today. Firstly, thank you, Jyoti, for sharing valuable insights on data sharing, clean rooms, which are very helpful at current market to solve many business problems. Along with that, today we are also going to discuss on advanced tax strategies. So before diving into the topic, let's begin with the introduction on RAG. So as we all know, RAG stands for Retrieval-Augmented Generation, which is a very powerful framework where it leverages large language models. The main advantage of RAG is we don't need to fine-tune or train the data to the model. Instead, we embed our data in our own secure database. From there, we retrieve the data and we pass it to the model to craft our final response. RAG mainly consists of two phases, one indexing phase, another one retrieval phase, or we can call it as querying phase. In indexing phase, there are multiple steps involved, like extracting the text from our data, chunking the text, and passing these chunks to the embedding model to generate embeddings. And once we generate these embeddings from the embedding model, we store or index this to our vector database. So in retrieval phase, we set up chains where we leverage llama index or lang chains or haystack and associated with our language models. Here, we retrieve the information from the vector database and pass this information to our final LLM to craft our final response. So today, we're going to discuss one advanced RAG strategy in indexing phase and one advanced RAG strategy in retrieval phase. So in basic RAG, we use fixed size chunking, which means we split the text into chunks based on set of numbers or characters or tokens. In LangChain, we use character text splitters to perform this kind of chunking. Moving on to paragraph-based chunking. Here, we chunk the text in natural paragraph boundaries. In LangChain, we use recursive character text splitter to perform this kind of chunking. So now talking on advanced strategy in indexing phase, which is semantic chunking. Here, technique like top modeling can identify semantically coherent sections of our text. And based on that, it divides, it groups the text and converts it into chunks. So in LangChain, we use semantic chunker to perform this kind of chunking. So going a bit deep into semantic chunking, there are 4 types of semantic chunking, or else we can say there are 4 types of threshold in semantic chunking, which are percentile, standard deviation, interquartile range, and gradient. So in percentile, before going into this, so initially what we do is we calculate all the similarity scores of the text. And then moving to percentile, here we determine a threshold using the X percentile. For example, if you are setting up the percentile threshold to 0.9, then the data is chunks the scores below this threshold. These are best for general use cases and for balanced chunking, and where it produces semantic coherence. In standard deviation, we compute mean and standard deviation of the scores, and we set thresholds based on deviation from the mean. So then we group the chunks with significant score differences. These are best for identifying chunks that significantly deviate from the norm. So in interquartile range, we calculate the IQR using 25th percentile and the 75th percentile. Based on that, we split the chunks which scores outside of this range. And these are best for handling outliers. In gradient, we compute the change in similarity scores, we identify them, and we split these chunks based on the significance scores. These are best for detecting and chunking based on subsequential content data. So moving on, this is one kind of advanced strategy in indexing phase. So once we chunk using the semantic chunker, then we pass this to our final embedding model, and then we generate embeddings. This will be stored or indexed into our vector database. So here we have completed phase 1, which is indexing phase. And now in basic RAG, in retrieval phase, we use chains. And from there, we retrieve the information and we pass it to the LLM and we craft our final response. Coming to advanced retrieval phase, here we use query transformations, also known as multi-query retrievers. So here, initially, we set up an LLM and we prompt it to generate multiple queries. And whenever we pass the initial query to this LLM regenerates the query with different perspectives of the original query. And now when the LLM generates queries, so these queries will go into vector database and retrieve the relevant document. So here we apply scoring algorithm where we calculate the fuzit scores and then we pass this to the re-ranker. So this re-ranker ranks the highest similar scored document for the initial query, and then this will be set as context to our final LLM, and this final LLM will craft our final response. So these are the 2 advanced RAG strategies, one in the indexing phase where we use semantic chunking with different threshold types, and in retrieval phase we used query transformations. Now moving on to the demo. So now I'm logging into Databricks. So for demo, we are using financial data, and we are using 15.6 Scala, which consists of 8 crores cluster. And to start with, let's start configuring for our end-to-end advanced RAG application. So here we have configured our catalog, we have configured our schema, we have configured our vector search, which we are using Databricks as our vector database, and we have uploaded all our financial data to the volume. And moving on, the next step is to configure our final embedding model. So here we are using Databricks GT Large English as our final embedding model. And we have configured our embedding as well. And we are configuring our delta tables. So where we store raw files into the bronze table, where we store parsed documents into the silver table, where we store chunked documents into the gold table. And finally, the gold index for the vector index. Now, we have completed configuring our tables as well. Now we will configure our chain to retrieve the information. So here we are using Databricks DBRS instruct as our final LLM to craft our responses. It's always a good practice once when we have done our configurations, it's always a good practice to validate our configurations. So here my data was uploaded and the volume exists in the Unity catalog, and my Unity catalog is validated, my schema is validated, and we are yes, and vector search endpoint also is validated. And it's always good to check whether our final LLM and our embedding models are ready to serve or not. Here we can see our models are ready to serve. Let's get started building our data pipeline. As a first step, let's load our data from our Unity catalog volume. So our data was in this part in Unity catalog, and then we were writing these raw files into the branch table, and there we were saving this table to our Unity catalog. And once we have uploaded the data, we can see our data. This is our financial data, which with pretty decent length and characters. And now we need to set up our parser. So for today, we are using PyPDF as our parser. And we have created a user-defined function. So Spark can parallelize this data processing. So here we are running the parser and saving this to the branch table. So here we are extracting the text from our financial data, and we are writing back to the delta table. So here if we see, so this is our path, these are our files, this is our length, and this is the extracted text from our documents. Moving on, the next step is chunking. As we are building advanced RAG with semantic chunking. So now, as discussed in the earlier slides, so initially we initialize the embedding model to calculate the scores, and we have created wrapper class for embeddings here, and we have created instance for the wrapper, and here we are saying take the parsed content from the branch table and set up the threshold to percentile and perform the semantic chunking with the help of the embedding wrapper, which we have created just now. And once we have configured our breakpoint threshold, which we have set to percentile, and here we are extracting the parsed content and we are passing to this semantic chunk. And here we are filtering out any empty chunks. And here we are defining a user-defined function for chunking. And finally, we have filtered, and we also filtering out unsuccessful chunks and successful chunks. And here we are writing back these chunked files into our delta table, which is bold. So now if you see, we have loaded our Hugging Face model to calculate our similarity scores, and we have initialized our wrapper. We have applied semantic chunker user-defined function, and we have filtered our chunked files, and we have written back to our delta table. So with the help of, and we are enabling CDC for our vector search delta sync, where to create vector images. So here we have set up the threshold to the percentile. So it has produced 28 chunks. So if you see here, so these are all semantically chunked based on the threshold type percentile. So in the same way, let's observe for the other threshold. Here we are set for standard deviation, and let's see how many chunks it produced. Yes, here it have produced 9 chunks. That means our data, which we indexed, does not have any significant change in the similarity scores. And let's check one more. So now we are setting our breakpoint threshold to interquartile. And now let's see how many chunks were produced with this. So it produces 32 chunks. That means our data doesn't sense any outliers in the similarity scores. And all this data was nicely sitting in our delta tables, which is gold. Now, for our end-to-end advanced RAG application, we were using percentile as our threshold. So here we are embedding the chunks and we are initializing our vector search client. And here we are creating our index with the help of final embedding model, which is Databricks large English. And once we have initialized this and our database and our vector database gets ready with our data. So it's always good to check the tables whether it's created or not on vector database is created or not. These are the endpoints for our vector index. And this is our endpoint for bronze tables. And this is for silver table with parsed files. And this is for gold table with chunked files. Now let's test our index, whether it's working or not. So here we are asking a question from our financial data. So asking what is multifamily loan, and I was using similarity search function on vector database. So here we can see it retrieved the relevant document with the score of 0.7. So which is we have successfully indexed our data into vector database. And the next step is, so till here we have completed the indexing phase. And then now the next step is retrieving phase. So here, as discussed, we are using query transformations. So I was using OpenAI for rewriting and for generating queries, different perspectives of the original query. So I'm passing my OpenAI API key, and I'm using Databricks DBRS instruct for my final LLM to craft the response. And I have configuring my Databricks vector search as a retriever. And then I have created a prompt template saying that whenever the LLM gets an input, I'm asking it to write into 4 multiple queries. So once we have done that, here I was saying to retrieve the documents of the 4 generated queries. And here we are using ranking algorithm to calculate the scores. And then we are passing to the re-ranker to fetch the highest scored document. So once the highest scored document is retrieved, so here we are setting up this document as a context for our final answer. And we are passing this document to our final LLM to craft the responses. So here we see. So these were the generated queries for our initial query. And these were the documents retrieved. And this was the this was the ranking score of the document. And here we are passing to re-ranker. And here we identified this document is the highest scored document. And then this we are passing as a context for the final answer. And here we can see the final LLM crafts our final response. Once we have implemented this, we have done semantic chunking in indexing phase and query transformation in retrieving phase. Now it's time to test our application locally and deploy it. So here, just to test, I have changed the query. So I'm asking what are the unique qualities of multifamily when compared to the single family. So the final LLM crafts the responses by retrieving the relevant information from a vector database. So it says multifamily properties which are with 5 or more residential units. And so we can conclude that our chain is working properly. And moving on, let's deploy our application. And once we deploy our application, the Databricks provides a quick interface to review or to test our bot before integrating to our services. So here, this is our bot, which we have built with advanced RAG strategies. Just in the interest of the time, I have prepared a few questions. Let's start asking our bot. So we are asking what are the unique qualities of multifamily when compared to the single family. and it was fetching the results from our vector database and it passing to our final LLM to craft the response. So it was saying the main unique qualities are multiple income streams, professional management, valuation, market resistance, and with a pretty good detailed overview of each points. And also another best feature for in Databricks is the business can always provide feedback. Based on that, we can evaluate our RAG application, which we have discussed in our previous webinars. Also, we can view the document. So from where the similar document for this question. And yeah, thank you. Sorry, where we here at FocalCXM, we are working on multiple projects and prototypes where we implemented these advanced RAG strategies, and we have seen immense boost in the accuracy and also decreasing model hallucinations as well. And thank you, Databricks, for providing these amazing services for building generative AI applications. Thank you all. Have a good rest of the day. I'm handing over to Mary for Q&A.
All right. Thank you, Jyoti and Aditya. We really appreciate you taking the time to share your in-depth knowledge with us. We do have a couple of questions, and I think we're doing okay on time. We'll try to get through these quickly. The first one is, how can we use Unity Catalog with Databricks Marketplace for better data governance?
Yes, Maria, I can take that. Definitely, Unity Catalog is mainly that's a unified platform on Databricks Lakehouse platform, which can enhance the data governance as well as the access controls. Primarily, the Unity Catalog can maintain the unified permissions of the users, onboarding users onto Databricks, and assigning role-based permissions. In addition to that, Unity Catalog has a complete auditing protocol. So we could generate audit logs in every user action and to the lowest level granularity as possible. So that maintains a lot of security of the data and every interaction of end users on the data. So that maintains the transparency and accountability of the data. In addition to that, like normally the data discovery, cataloging, all that is very seamless on Unity Catalog. And there's a unique feature on Databricks Unity Catalog, which is data masking. So there's a table which has a PII information of collaborator 1, and collaborator 2 can reuse all the table except for the column which has PII data. Then Unity Catalog can enable data masking of that column. So that way collaborator 2 can directly consume that table with that column stripped out of the whole schema. So the whole other data set can be used, which is non-sensitive, which makes it public data set, non-sensitive data set, and then it can use column masking. So that way there's a lot of security which Unity Catalog can provide for governance of any data sets which are on market share, marketplace, delta share, or clean rooms.
Okay, so there's another question here that is data encrypted in the clean room or in clean room, and how is integrity of data in clean room maintained?
Definitely. The integrity of data include, that's a very good question, because clean room actually is like a safe, secure space for both the collaborators. So, and in addition to that, because it is completely on the Lakehouse platform, so any tables provider is trying to build any Delta Lake tables, all those Delta Lake tables and data is being onboarded directly into Lakehouse platform, which is integrated with Unity Catalog. So table level access, catalog level access, schema level access, column level access, still that granularity, we can always maintain the whole role-based access control with Unity Catalog. In addition to that, like data access policies can be set up, data usage policies can be set up. So that way the compliance and regulation of the data which has been onboarded into clean rooms can be maintained. In addition to that, the agreements which are made, mutual sharing agreement which has been made by the collaborators on the clean rooms, also makes sure that the mutually accepted jobs, mutually accepted notebooks only could be run on clean rooms, because clean room is like a centralized space within Databricks server, which is provided for both the collaborators so that they can share their data sets, and at the same time they can share on only agreeable data. Any new data sets cannot be onboarded on that. And even though the collaborator one is the provider of the data set, but still they would have the same level of access controls as the recipient. So that way, the clean rooms maintain a lot of security and integrity of the data, and column masking, encryption, all these additional features of Unity Catalog would make sure that the data at rest, the data in transit, everything is following the security protocols.
Great, thank you. Another question. What are the performance implications of using data products from Databricks Marketplace?
Yes, that's a very good question. Because data of when as a recipient, for example, I'm a recipient of data on Databricks Marketplace. That is not data which I have directly built within my platform. For example, I don't have Databricks. I'm using some AWS RDS or any other infrastructure for that matter. I'm trying to use Delta sharing and directly taking a data set from Marketplace and onboarding that data set within my platform. So the main challenge would be here is latency of the data. So here, because it's an external third-party data set which I'm trying to use from Databricks, but Databricks Marketplace makes sure that the egress cost, the data provider has a level of thresholds on the egress. So every data which is flowing from Databricks Marketplace to any third-party cloud provider is live, near real-time data. Directly near real-time latency would be maintained. And also the whole platform, Databricks platform, is serverless and high scalable and highly available. So that makes the data usage of the data as a recipient very easy and less latency and highly available. So that way I can always rely on performance of the data which is coming from third-party Databricks Marketplace. In addition to that, the whole platform is photon based, which accelerates queries on the Databricks. So that way, like, it helps in performance of complete model or analytics which has been built on external data sets.
Thank you. We have one final question here. How can we ensure compliance with data governance policies in a clean room?
Yes, that's definitely a continuation of one of the previous question. Mainly, compliance of clean rooms that's definitely a concern for every organization, because data sharing sounds great, clean room sounds great, but enterprise level data is definitely so secure. Even many of the organizations have data within the on-prem, and migrating to cloud also poses risk. So sharing data with another collaborator definitely has many questions and concerns. That's the main reason where the data access policies and usage policies needs to be clearly defined when onboarding data onto clean rooms. So the best practices and configurations make sure that the whole data which is being onboarded into clean rooms have fine-grained permissions, audit logs, and then sensitivity data handling, audit controls, and monitoring. So much monitoring and usage tracking needs to be happened. And at the same time, the provider of the data is managing the costs of the data flow. So the ingress and egress costs of the data moving from provider to recipient is bared by the data provider. So that is also a part of agreement. So all this would need to be taken into consideration to maintain compliance of the whole clean room data.
Great, thank you. Well, I think we're about out of time here, and that's the end of the questions for today. So thank you, everybody, for coming. You will be able to find this recording at our website, FocalCXM.com, in upcoming days. Thanks again, Jyoti and Aditya.
Thank you, everyone.
Thank you all. Have a good rest of the day.
Thanks. Bye-bye.